So, what we saw was that shape is a shape, one can compare with the cube, what is known as thermal cube. Just let us see, we are doing this for heat loss scenario, where we would like to minimize the heat loss, because that is simple to understand. And then when you want to do it for some tropical conditions where minimizing the heat gain is a concern, we will have slight modification. So, let us say the total area of the total wall is AW, some wall, area of the corresponding glass is AG, then we write it as a ratio, AG is equals to RAW. So, this such that is just a ratio of the proportion of the glass in the total wall area, proportion of the glass in the total area. So, area of the solid portion is 1 minus R into AW, AW is the total area. So, heat loss per unit temperature, then one can calculate out. So, U of the wall, now portion of the wall is 1 minus R into area of the wall, U of the glass into AG, U of the roof into AR, U of the floor into AF. One thing, most of the walls will have, supposing I have a, I am just looking at the boundary of the building. Now, all wall will have similar construction. It is unlikely that one wall is of one construction, and let us say simple case you are dealing with, you can complicate it for large building and things like that. Now, UA ARW. So, what you can write is AG is written as a RAW, and roof and floor area usually will be same. So, I am calling this as AF equals to AR and writing is at AR, and this is UR plus UF therefore. So, everything is expressed in terms of AW or AR. So, UA 1 minus R AW UG RAW plus, let us say average of UR plus U roof is divided by 2, okay, divided by 2 is this divided by 2 is equals to U. So, then UR plus UF will be 2U, UR plus UF will be 2U into area of the roof, and this we can write as if I put a ratio of UW divided by U as R1, then I can write, I am just putting everything in terms of this U, and then this is glass, U glass divided by U is equals to R2. So, I can get it in terms of 1 minus R AW, and R2U gives me U glass twice UAR, and AR is equals to nothing but alpha beta square H square, because L is equals to alpha beta H, B is equals to beta H. So, L into B is alpha beta square H square. Area of the roof will be area of the roof will be what? L into B. L is equals to alpha B, B is equals to beta H. So, this will be written as alpha beta square H square, area of the roof, right. So, that is why the first time looking at that portion, we will come to the tropical scenario a little bit later. So, AW is area of the wall is 2L plus B into H, length plus breadth, twice of that into height, considering this. So, 2 alpha plus 1, and both will have beta BH can be taken out, and this is BH square. So, volume is wall area is 2 alpha plus 1 beta H square, volume is alpha beta square H cube, right, volume is alpha beta square H cube. So, heat loss per unit temperature per unit volume can be written like this, because we said R1, which was a ratio of U bar is the average of roof and floor U values. So, this was the ratio of wall, ratio of wall u value, ratio of wall divided by the u bar. So, this is nothing but uw 1 minus r, putting this 2 alpha plus 1 area of the wall, and this is related to glass, this is related to glass area. So, r is the ratio of the glass portion, right. 1 minus r is the solid portion, and r2 is the ratio of the u values of glass divided by that of the average of roof and ceiling. So, we just write it like this, and this plus, that is for the roof and ceiling put together. This is the area of the roof twice, area of the roof and the floor together into u, and this is the volume of the room. So, per unit volume you can calculate out all in terms of all in terms of alpha, beta, h, alpha, beta, h and u bar, everything can be expressed in terms of u bar, because we are saying u w by u bar is equals to r1, u glass by u bar is equals to r2, and this is directly u bar, and ratios, this r stands for area of the glass divided by total area of the wall, 1 minus r is the solid portion of the wall, and that is how we have done. And then alpha is equals to L by B, beta is equals to B by H. So, everything can be expressed in this term. So, this is simple algebra, and then divide by the volume, which is alpha beta square h cube. So, this you do a little bit of algebra, you get something like this, twice u bar by alpha beta h r1 1 minus r, etc., something like this you get an expression like this. You just simplify this, you will get an expression in this manner. For cube having same volume and divided by, of course, per unit volume, say let us say u bar is the uniform u, and I have 6 surfaces, heat loss per unit, temperature per unit, volume will be given, because everything is u bar. It is a cube. So, what is the surface area? 4 cube. So, 4 h 0, this is h 0, this is h 0, this is h 0, this is h 0, right. So, h 0, basically h 0 square is the surface area of the wall, h 0 into h 0, and 4 such cases, twice u bar h 0 square divided by h 0 cube, right. 4 walls, the ceiling and the roof, everything has got their size as h 0, because a cube, volume is h 0 cube, and u bar is a uniform u throughout all 6 surfaces, got. So, this is called a thermal cube, and if you compare this, this will be 6 u bar by h, 6 u bar by h. So, this divided by this, if this is 1, that is the best, or as close to 1. It will never be 1, it is as close to 1, that is a better one. So, for various buildings you can actually choose, for various building you can choose and compare, find out which gives most close to 1, whichever gives most close to 1, that you can choose, right. So, that is repetition of the same thing. So, this actually would be written something like this. Finally, if you do this algebra, this divided by 6 u by h 0, if you do it, then you will get this divided by 6 u bar by h 0, you will get u bar will cancel out, h will remain, alpha, h will remain, it will turn out to be h by h 0 is equals to alpha beta square by 1 by 3. So, you can choose alpha and beta to see that how close it is for various values of alpha and beta. You can find out this ratio, or this should be as close as 1, this should be as close as 1. So, you can find out from this one, you can find out from this one, you can find out from this one alpha beta and h 0 with one of them, the other you can actually find out, right. So, that is related to this one, Now, if it is summer condition where heat gain is a concern, you want to minimize the heat gain, then this radiation you must take into account, right. So, Qcd conduction gain is this much UATA and alpha by H naught, alpha I by H naught into, it should be a bracket here, otherwise this will create problem. Glass Ag, area of the glass, I into theta, solar gain factor. So, you define now something like Fg, which is I theta. So, you can write it at U RW I alpha AW. You know, this can be written as area multiplied the rest of the thing. Okay. So, you know where the question is we want to minimize the summer gain. So, summer conduction gain is given by UA, TIA minus TOA, or whichever way it is, TOA minus TIA, plus the radiation gain through opaque bodies, or if it is glass, then this will be through Ag into I into theta. So, we define instead now a term F stands for in this case, you know, stands for everything other than area, such that A W F W I can write like this: U W R W I bar alpha, alpha I 1 over H O I call it R O into U. So, this is what corresponds to F W for solid portion of the wall. For glass, it would be A G into, I mean leaving A G I theta. So, this is F for the glass. So, F G for glass we are calling it this way. So, A G F G is equals to A G I theta. So, A R F R for the roof, I will have area of the roof, resistance of the roof alpha, and there is the radiation received, there is solar radiation minus long wave radiation loss, or I might neglect this part, I can simply take for the roof I can simply take like this. So, similarly Ag can be written as R into AW like we did earlier. So, an expression we can obtain in the same manner, radiation transmitted through the wall will be given as R AW, because this is for the solid portion of the wall, sorry, this is for the glass portion of the wall, into AW Fg, Fg stands for I theta. So, that is the heat gain through the radiation heat gain through the glass. 1 minus R is the solid portion of the wall multiplied by area of the wall into Fw. What is Fw? Fw stands for I alpha R naught into U, I alpha I R naught into U, all for wall, all for wall. So, that is what it was, and for any wall you can find out this, for nth wall you can find out in this manner. Total radiation transmitted into a building is from 6 surfaces, heat gain will be through building from 6 surfaces A1, F1, A2, F2, A3, F3, A4, F4, and actually 6 surface we will omit out, because floor will never receive the radiation. So, it is actually 5 surfaces, floor no radiation. So, 5 surfaces transmitted into the building from 6 surfaces includes only 5, because the 5th one will not be, the 6th one will not have anything. Now, we can assume F13 is equals to F1 plus F3 by 2, that is normally this wall and this wall will have similar, this wall and we will have this wall will have similar properties. So, we can say that F13 stands for F1 F3 divided by 2, for area of the area of, generally areas will be A1, A2, A3, A4. So, area of A1, A3 are same, A2 and A4 are usually same, this is like this. So, we define F24 as F2 and F4 divided by 2, F1 to take the average of these 3 and call it F13, trying to simplify this. F stands for the amount of heat gain through the surface per unit area, due to we are taking only radiation into account. UA part is not important here, because orientation and shape controls, because you see outside air temperature is same. So, the shape and orientation will be controlled largely by radiation heat gain. So, we are trying to minimize the radiation heat gain, right. So, total radiation gain would be given by A13, because 1 and 3 will have same area. F13 is the average of their F values, and similarly for the other two, and this for the roof. The floor is not to be considered, because it will not have any radiation gain. So, therefore, orientation and shape really do not depend upon the the floor area. It is, I mean, the radiation received would be on largely on the 5 surfaces, right. So, what I say is A13 then can be written as alpha b h square, like we did earlier, alpha beta h square, because L is equals to alpha into b. This should be, this is A13 is equals to alpha into b into h, right, L into h we are saying. So, this is nothing but b is equals to what? B is equals to beta h. So, this will be alpha beta h square, and this will be beta into h, and b into h, and b I am writing as beta h. So, beta h square. So, these two areas are something like this. And what about this? This will have L b is the area, which is nothing but alpha into b square, and b is nothing but beta square h square, b square will be beta square h square. So, this is alpha beta square h square f r twice beta h square f 2 r, and right. So, this is the total radiation gain depending upon the orientation, and I can take beta h square common from everywhere, beta h square common. So, this will have alpha beta f r, this will have, this is already taken out twice f 2 r, and from this I am taking out beta h square common. So, I will have 2 alpha f13 etc., etc. This is the radiation. You can calculate out for various values of alpha and beta, and again minimize, or little bit simplification if you want to do f12 by y, some ratio I can talk about in terms of ratio, y24 and y12. Y12 stands for f12 divided by f13, it should be f13, y13, and 24 is fine. So, 24 is fine, f13 it should be. So, total radiation is, this I am calling as y13, y24, etc. Radiation per unit volume I can calculate out. What is the volume? Alpha LBH. So, alpha then b square h cube, that is the volume, and b square is equals to how much? Beta into, so beta, this, sorry, this is h only. So, this is h cube alpha beta square h cube, alpha beta square h cube. The volume is, L is equals to alpha b equals to alpha beta h, b is equals to beta h. So, alpha beta square h square multiplied by h. So, this is what I get it. So, total radiation per unit volume I can calculate out, and total radiation per unit volume if I calculate out, this will be, this was this, if you remember, total radiation was b h square f r. So, I take out alpha beta, alpha is not coming out, sorry. So, beta gets cancelled out, beta will get cancelled out because I will divide by alpha beta square. So, this divided by, just let me do this. So, beta h square f r into twice alpha y13 plus twice y24 plus alpha beta f r, and this I am dividing by alpha beta square h cube. So, what I get? This beta cancels out. So, I am left with alpha beta here and the h here, and rest of the thing remains as it is. So, this is the radiation per unit volume, this is the radiation per unit volume, and this has to be radiation gain per unit volume, this has to be minimal. So, it is a simple calculation that would tell you how to find out, that is a simple calculation how to tell you, to choose a shape for minimum radiation heat gain, right. So, this is minimum radiation heat gain. For if you now try to find out for equivalent ideal cube, which has got FR as throughout and radiation per unit gain per unit radiation gain per unit volume will be 5 FR divided by H naught. Why 5 instead of 6? Because there are only 5 surfaces I am considering. Bottom surface will not have anything. So, ratio one can calculate out, this should be as close to as 1, or you minimize simply this value you minimize, find out various values for alpha beta values, choose one of them, other one you can find out. So, find out whichever is least, right, for various values you can actually find out what orientation is better, right. The ratio is something like this. So, one can compare, and this ratio should be as close to as 1. The total volume is known. So, total volume is equals to H 0 cube, total volume is equals to H 0 cube. So, H 0 you can obtain from the volume and put it here for various values of alpha beta, you can tabulate out this value. This should be as close to as far as close to 1, least the value minimum will be 1, anything as go away from 1 it would be less efficient, the shape will be best if it is close to 1, right. So, that was related to shape. Now, let us look at glass. And somebody asked me a question the other day, why does why does glass allow solar radiation, does not allow long wave radiation, some ideas are here. Glass is a poor conductor, okay. So, we will break then go to glass.